students, we have been learning very interesting paper from your DYBSc semester 3rd course. It's Computational Botany. From that Computational Botany, today we have to get idea about very interesting unit, that is unit number 4, measures of central tendency. From measures of central tendency, we have get idea about mean, mode and median. Here, first, what is the central tendency that we have to understand? Actually, central tendency is nothing but it is a values of variables have a tendency to cluster around a particular value, and such a tendency is known as a central tendency. Most important thing is that in case of this one, is the clustering takes place of values of the variables around a particular value, and such a tendency of a values of variables is known as a central tendency. Now, what are the properties of a good measures of a central tendency that we have to learn here? First, most important property is that the measures of central tendency is rigidly defined, isn't it? It should be rigidly defined. It should have one and only one interpretation, so that personal prejudice or bias or partiality of an investigator should not affect the value. That is the second one. Third, that is the measures of central tendency should be easy to understand and calculate. It should be based on all observation. Most of the things never covers or never take into consideration the all observations, the all items of the set of data, isn't it? Again, it should have a sampling stability. If sample changes, the measures of central tendency changes. So that should not happen. It should be having a sampling stability. Again, the whatever measures we have taken, that measures have capable of further mathematical calculations. Again, another most important property, that is it should not affected by extreme values. What is that? Suppose we are having in our hand the observations that are the 10 in number, isn't it? 10 observations are with us. For example, I will tell to you, suppose we are having 10 students and we have to take out the average value, and out of that 10 students, 3 students are having a height that is a more than 6 feet and other are below 4 feet. Meaning extreme values affect on the exact average of that one. So we cannot be able to give a justice to the each and every. Suppose that average height is going to come, that is a only 4 or 4.5, and 3 students are above 6.5 or 6 feet height is there. So there is no justice given to that one. So, isn't it, extreme values should not affect good measures of central tendency should not affected by extreme values. Now, there are commonly used measures of central tendency are 3: mean, mode and median. Now we have to get idea about simple arithmetic mean, isn't it? The most popularly and widely used measure of representing the entire data by one value is what layman call to that is average, and statistician call to that as a arithmetic mean. Now, how to calculate simple arithmetic mean? This value is obtained by adding together all the atoms or observations or the figures present in the data and dividing the total by the number of not atoms but items or observations or observations. You have to keep in mind, not atoms, items are there. For example, I will tell to you so as to understand about this simple arithmetic mean calculation is that suppose in our hand we are having 100 mango fruits. How many? 100 mango fruits are in our hand, and somebody asked to you what is the average weight of that one, isn't it? Average weight. So we have to take weight of 100 mango fruits, then that figure we have to sum up all these things and divided by 100, isn't it? Divided by 100 because we have taken into consideration 100 fruit of mango, isn't it? And value will be the average of weight of fruit. Now, what are the merits of simple arithmetic mean? Friends, you have to keep in mind, it is a simple. There is a merit of that simple arithmetic mean. It is a simple for what to understand, and another that is easy to calculate. This is the most important merit of arithmetic mean. Again, it is calculated by the formula, therefore it is well defined, isn't it? In case of calculation of simple arithmetic mean, there is not necessary to arrange the data as required in case of median. So next we have to learn about the how to calculate the median. In case of the median, whenever data is given by anybody, the data we have to arrange either ascending or descending manner, isn't it? But in case of simple arithmetic mean, there is not a requirement to arrange the given data in ascending or descending order. So that is also one of the most important merit of the simple arithmetic mean. Also, it provides a good measures for comparison between two or more groups. Comparison is possible. Example I will again give to you. Suppose we have taken 100 mango fruits from one of the mango garden or orchard, that is A. Another 100 we have to say that the fruits taken from another orchard or mango garden, that is of a B, and we take the values of that one, arithmetic mean of these two, separately of each we have to say that fruit weight of mango, and then we can compare that A with B. Either the fruits from A garden are having a highest weight or higher weight as compared to the B, or less as compared to B, so that we can compare the things very well. It takes into account all the observations, isn't it? That is most important. All observations in the sense, suppose we have to calculate the average weight of a mango fruit from the A orchard. At that time we have to take the weight of each and every mango plant and make the sum of that one and divide by 100, and the value that is the, so here we have considered the all observations, all we have to say that taken into account here just to calculate the simple arithmetic mean. It is not affected by the fluctuation in the sampling, also one of the merit. It is most reliable, we have to say that mean, which is used for taking out or drawing the inferences about the population. For given set of data, there can be the only one mean, no more than 1 means we can take out or calculate from the given data. Therefore, it is a unique one. Limitations are also there with the, we have to say that, arithmetic mean. It is largely affected by extreme values. Already I have given you example, isn't it? It does not consider increasing and decreasing trend. It is a good measure of central tendency only when the distributions are bell shaped. If distributions are U shaped, then it is not useful, isn't it? In some cases, it may not actual value of a variable. It cannot be accurately determined even if one of the value is not known, isn't it? So this is also demerit. It cannot be calculated in open-ended classes without making assumptions about the size of the class interval. So these are the demerits of arithmetic mean. Here, my friends, one of the example is there, that is from the following data of the marks obtained by 60 students of a class. Calculate the arithmetic mean. Here already I would like to give you idea that we are having in the class 60 students are there, and they have obtained the marks, that is of a 20, 30 and 40. The 20 students obtained 20 marks obtained by 8 marks, 20 marks obtained by number of students, then 8, 30 marks obtained by 12 students and 40 obtained by 20 students, isn't it? Again, 50 marks obtained by 10 students and 60 marks obtained by 6 students and 70 marks obtained by 4 students. So first of all, you have to understand the exact what we want to get idea about the problem. What is our problem? Problem is that in the class 60 students are there, isn't it? And marks obtained by them, that is 20, 30, 40, 50, 60 and 70. But 70 marks are obtained by only 4 students, 60 marks obtained by 6 students, 50 marks obtained by 10 students. That's it. 40 marks obtained by 20 students, 30 marks obtained by 12 students and 20 marks obtained by 8 students. Total students 60, isn't it? Now we have to calculate the arithmetic mean of that one. So let us the mark be denoted by x and number of students denoted by f, that is the frequency. Marks denoted by x, 20, 30, 40, 50, 60, 70. Frequency, the number of students those who have obtained the marks, 20 that is 8, 30 that is 12, 40 that is 20, 50 marks obtained by 10 students, 60 marks obtained by 6 students and 70 marks obtained by 4 students. So number of student observation, that is the 60. Now fx, this frequency multiplied by obtained marks. So this value 160, 20 into 8 is there, 12 into 30 that is 30, 360, then 40 into 20 that is 800, then 50 into 100 that is equal to 500, and 60 into 6 that is equal to 360, and 70 into 4 that is 280. Summation fx, so total of this is 2460 is there. Formula x bar, that is arithmetic mean, is equal to summation fx divided by n, that is number of observations, number of students, that is 60. So 2460 divided by 60, that is equal to 41. Hence the average mark of that class obtained by the student, that is 41. So like that you will have to solve the questions given into your book. Now average position. There are two main objectives of average position: to get the single value that describe the characteristic of the entire group of central tendency by condensing the mass of data in one single value, enable us to get the bird's eyes to view the entire data. Thus, one value represents thousands, lakhs, or even millions of values. To facilitate comparison measures, even millions of values. To facilitate comparison measures of central tendency by reducing the mass of the data to one single figure or enable the comparison to be made. Comparison can be made either at the point of time or over the period of time. So this is the average position is there. So one sentence I will tell to you, in our hand we are having 1,000 lakhs of observations, but we have to take out from that one with the help of arithmetic mean, or sorry, average position, single value, and that single value represents the whole data. Now, advantages of median, isn't it? It is easy to calculate and easy to understand. It is not affected by extreme values of the data. It's very useful in case of qualitative data. The value of the median can be easily determined graphically, whereas this is not possible in case of the mean. Most important thing is that it indicates exactly the middle items and hence it can be easily explained. It can be determined by mere inspections. It is useful when the classes are open and when the distribution is asymmetric, isn't it? Then also it is possible to give out the median value. Demerits, disadvantages of the median. For calculating the median, it is necessary to arrange the data where as other averages do not require such a arrangement. In case of calculation of median, what we have to do, we have to arrange the data either ascending or descending, but such a type of things are not required in case of other measures of dispersion, measures of central tendency, or we have to say that in case of mean and mode. If the number of observations is in a large, the process of arranging data is a tedious and time consuming. Median is based on the middle observation. It does not take into account all the observations, isn't it? At the time of all the observations are not considered here. It is largely affected by sampling. Sampling fluctuations there, definitely there is a answers or median value get, we have to say that, affected. This is not the case of average mean. And another most important demerit, we have to say that I have said the important because in the sense median value cannot be used up further mathematical analysis, because median value have not that much, we have to say that, correct value. So that is demerit of a median. Now how to calculate the median? Here the formula is there. The example we have to see, when odd number of values are given, find the median for the following data. So this is the example: 25, 18, 27, 10, 8, 30, 42, 20 and 53. Arranging the data in increasing order. First of all, solution is that 8, then 10, then we have to say that value comes 18, then value comes 20, 25, 27, 30, 42 and 53. So here this data is arranged in a increasing order, isn't it? Observations taken from the given. Now the middle value is a fifth atom. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So middle value is the fifth atom, that is 25 is the median. Now we have to use the formula. Formula is that n plus 1 divided by 2, isn't it? How many observations? N is nothing but the observation. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is there. So 9 plus 1, 10 divided by 2, isn't it? So that is fifth atom. 10 by 2, that is the atom, that is fifth atom, again median is 25. So this is the formula. With the help of that formula or by the inspection also we'll be able to calculate this value of a median. Now again the data is given here, problem is given to us, and this problem we have to solve and find the median size of the family. Number of members 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12 are there. These are the x value. The number of members 1 in the family. How many family are there? Only 1. Number of members 2. How many families are there in the society? 3. Number of members 3. How many families are there? 5. Number of members, that is a 4. How many families are having a 4 members in their family? 6. Like that 11 members are occurred or present in the family, that is a 2. 12 members, only one family is there having a members, that is okay, 12 is there. So why I have going to give this idea? Because first of all we have to understand the problem first, and then it would be very easy to solve the problem and come to the conclusion or to give the answer. Now what here, x is the x, then f, that is frequency, members, number of members we have considered here in x, and number of families we have considered here as the frequency, and cf, it is the cumulative frequency is there. How to calculate cumulative frequency? This is third column that I will give to you idea here. Here suppose 6 is there, isn't it? 15 value is there from column. So 15 plus 10, 25. 25 plus 13, 38. 38 plus 9, 47. Isn't it? 47 plus 5, 52. 52 plus 3, 58. 55 plus 2, 57. 57 plus 2, 59. 59 plus 1, 60. So cumulative frequency, it is possible to calculate like this, isn't it? Now the median, that is equal to size n plus 1 divided by 2, isn't it? So n value is a 60. Number of families, isn't it? Number of families, that is okay, 60 plus 1 divided by 2, that is 30.5 atom. So this number family, isn't it, is the median atom out of that one, isn't it? So median size, that is okay, 30.5, isn't it? So this is the answer. Now another measure of central tendency right now we have to learn, that is okay, mode. That is okay, mode. What is definition of mode? Mode is nothing but refers to that value in the distribution which occurs most frequently. Value in the distribution which occurs most frequently, that is nothing but the mode or value of mode is there. Example here, suppose this is actually the size of one of the pod in centimeter, 2, 7, 20, 16, 2, 5, 2, 2, isn't it? When we'll see this actually the data or example, we will see that the definition is what is that of mode? Value in the distribution which occurs most frequently. So here 2 value occurs in a 3 times, isn't it? 7 value occurs 1 time, 20 occurs in 1 time, isn't it? Then another value occurs in 1 time, 5 occurs in 1 time. Only 2 value occurs 3 times frequently. That's why mode is value is a 2. Now see another example. Here in A we can find the 8, 9, 11, 10, 10, 7, 6 and 12. So 10 occurs twice. That's why mode is a 10, isn't it? Now next value 6, 7, 8, 3, 9, 2, 1, 5. So here we cannot find a single value which occurs frequently. So there is a no mode. Keep in mind. Another third example, C example, we will see. So 10 occurs twice, 11 occurs twice. So there are the two values of the mode are there. That is 10 and 11. Two values are there, isn't it? So this is the way how to say that information about the mean, mode and median. With this I stop here. Friends, what you have to do, you'll have to go through the textbook, try to solve the examples, and that solving of example will help you to keep in mind or understand which formula where we have to use, how to calculate the mean, how to calculate the median, how to by inspection calculate the mode, that you will understand. With this, thank you.